Welcome to the Susan Brender Show. It's all about you. Featuring shows on health and wellness, the performing arts, politics, and people who inspire you to be your very best. And now, here's Susan Brender.
I'm Susan Brender, and this is the Susan Brender Show. Today I have a very interesting guest, and his name is Andy Ruina. He's a professor of mechanical engineering at Cornell. In his early years, he studied the friction of sliding rocks, trying to figure out how earthquakes work. Wow, interesting stuff. Now, the shaking of the earth, he says, is sometimes like the squeaking of chalk, only at a giant scale. Just even listening to that makes me squeam. Now, he's gone on to study the mechanics and dynamics of various things, including bicycle balance, the dynamics of chain and robotic sailing, and most of his research in recent years has concerned legged locomotion. Now, I want to welcome to my show Andy Ruina.
Hi.
You know, Andy, you in your bio, you say the big questions are how do people and animals do it, and how can we make a robot do it? So, give our audience an understanding of how people and animals do it.
Right. So there's two big challenges that animals and people sort of handle pretty well, which is they get from one place to another without falling down. And so that's challenge number one, is how do you get around without falling down? And then the second thing is they get there without using a lot of energy. It doesn't take a lot of fuel, it doesn't take a lot of food for an animal to get from one place to another. And meanwhile, if you look at all the different robot videos you can find on the internet, you'll see some are impressive one way or another, but what you'll see is all robots now either aren't very good at getting one place to another, they're slow and awkward, or they fall down a lot. Or the ones that look pretty good, they use tons of energy, way more energy than a person does. So do we really know how animals do it? I'd say in some deep way we don't know, but we know a lot of things about how people and animals balance.
Andy, is it even possible for us to create machine intelligence that can make nuanced distinctions? Like, I'll give you an example, such as between a gun and an ice cream cone pointed at it, or understand human speech that is often heavily based on context?
I would say I can give you an answer to that question, but that's not really my expertise. So let me tell you why I can't answer that question.
Okay.
So when people think about robots and artificial intelligence and so on, they think about these very high-level issues, like can you tell a gun from an ice cream cone? Whereas the kind of artificial intelligence that I mostly study is stuff that you don't even think of as being intelligent. So in this case, like when you walk, you put one foot in front of another, and it seems so trivial. And even insects can do it. Mm-hmm. And the thing about my whole area of research and people like me, what we do, is we realize that these things which you don't even think of as intelligent, we still don't understand them. So the things that insects can do, and small animals can do, and babies can do, as conscious scientists, we don't understand them. So we're working at a much lower level of artificial intelligence.
I see.
So the difference between a gun and an ice cream cone, the first time a monkey sees such a thing, they can't tell the difference. And we're interested in things which are way lower level intelligence than even things monkeys can do.
Yeah.
So we're interested in things that really low level.
So when did you begin this research, and what have you discovered?
I started this sort of walking research in about 1990s when I first got interested in it, and the way I got interested in it, I was visiting the lab of Mark Rabert, who went on to form this company, Boston Dynamics. So I visited his lab at MIT and spent some months hanging around there and watching him make hopping robots. And I was disturbed isn't quite the right word, but it bothered me that his robots used about maybe 100 times as much energy as a person or animal uses to do the same thing. So I started thinking about how do you make energy-efficient robots. And what have we figured out? I think we know sort of the principles of how to make a robot energy efficient.
Yeah.
So that's that's the main thing we figured out, is that we can now make robots that are just as efficient as people walking.
But now, tell me, many years ago, people were fooling around. They were kind of playing with the idea of robotics, and they were kind of just testing them out. How have we evolved since then? Because I now maybe you know when this all started, but I know that it was a very long time ago, and it seemed like it was just something that people felt would be possible, but they really didn't understand the science behind it. So tell me, how is it evolving since, say, maybe you were a kid?
Well, so let me tell you how it looked to me, is that once people started making machines in the 1800s, they started having this idea of machines that would mimic people. So there's a robot from The Wizard of Oz from, about 1905.
Sure.
It's just fiction, but it's this humanoid robot called Tick-Tock. So there was this concept that, people are victims of the laws of physics and science, just like machines are. So they should be able to make a machine that's like a human. And people at that time sort of imagined you have enough gears and cams and cables and chains, and you make a complicated enough clockwork, and you get something which is human-like. Mm-hmm. And I think one line of thought, and I think is still sort of popular among non-experts, is that you could mimic the intelligence of a person with machinery. And what's changed since the time of Tick-Tock is that it's not gears, it's transistors. Mm-hmm. And then what's changed in the past 20, 30 years is that you don't have tens or hundreds of transistors, but millions and tens or hundreds of millions of transistors, so that we can make, incredibly complicated machines compared to 19th century clockwork, because the inside of a computer has, a million more parts, a million times as many parts as a fine clock has, mm-hmm. or 10 million. So it's hugely complicated. But then you think, well, then we should be able to do all the great intelligent things that people do.
Yeah.
And I say the big insight that sort of everybody has when they come into this and start studying it is that the things that we think as humans are really smart are in some ways the easy things for computers, and the things that we think as humans are really dumb are the hard things for computers.
Right.
So, for example, we think of advanced math as a big advanced thing. Mm-hmm. Well, advanced math is something computers are really good at. Right. So, if you take a calculus class and you have trouble figuring out how to do integrals, well, there are computers now that can do integrals better than any human being. Mm-hmm. Or you think, chess that's very hard. Well, a laptop computer can beat all the top 3 chess players in the world. So the best chess player can be beat by your telephone, probably.
Right.
So these things which we think of as high, difficult intelligence are the kinds of things which are easy for computers. Mm-hmm. And the things that we do without a thought are the things that we don't, as scientists, we don't know how to make computers and machines do those things.
Right.
So, the one that's, the famous problem is the problem of vision. You just look and all your friends in a glance. You know them, and if they're wearing makeup, you can still recognize them, and you can recognize them from the back by the way they walk, mm-hmm. and you don't even think about it. In fact, you don't even know how to think about it. It's all sort of subconscious skill.
Sure. And
so that, the computer vision problem is a huge one, and they've gotten much better at it, like Facebook now can recognize pictures, but it's only recently, mm-hmm. and that's a very hard problem for a computer, whereas it's trivial for us. And the problem, let me just bring it back to my research. What we're interested in is making a robot that can walk, and it seems like this is incredibly dumb. All you do is put one foot in front of your other, but it turns out that at this point in time, October 2016, if we take the community of scientists who study this problem, we do not have a good way of understanding how people put one foot in front of another to walk.
Amazing.
So the big insight is that the dumb things are the hard ones. Or the way I like to say it is that we are much smarter below the ears than above the ears. Or another way to think of it is like it's an iceberg, and what we think of as the smarts is the top of the iceberg above the water, but all that stuff below the water line, that's really where our smarts is, and we don't have really any understanding of what it is, how it is, or let me say it another way: in the 2 billion years of animal evolution, only a little bit of it was this bit of human intelligence, which only happened in the past 2 million years. Whereas there's this billion years of other kinds of intelligence that all animals have, and that's much more sophisticated. It's just we don't have a good conscious understanding of it.
Right. What do you think Darwin would say about this?
I don't know. The evolutionary way of thinking things totally affects, if you're in this business, you think about evolution this way and that way and sideways.
Yeah.
But I think I could say that, this idea that human intelligence, which we're also proud of, is also recent compared to the whole evolutionary history of life on Earth. And it's sort of reasonable to think, that there's really not that much to it compared to all that evolutionary history of life on Earth. It's just a little frosting on the cake. And that's the part that we're aware of because the awareness is the frosting. But it's not maybe the deepest, hardest part.
Yeah. So Andy, how safe ought robots be prior to their introduction into the marketplace of society? Some people might think that these robots, who knows what they're going to do. If there's somebody crazy out there and they create a robot that does bad things, I mean, that seems possible, doesn't it? And do we have any controls, any regulations over it?
So this is just you're talking to me as a roboticist, as somebody who's around these things. I'm not a robot. I'm not a professional in answering this question, but I can tell you my thoughts.
Sure, please.
I think that if you just think about all the tools that humans have, that robots are essentially no different from any other tool. So if you say, let's just start out with where animals in the wild, and somebody discovers that there's a rock, and you can take a rock and you can hit somebody on the head with it, and you can throw it at somebody, and you say, how dangerous is that? Well, it's very dangerous, right? People can kill each other with rocks. You can kill people by accident with a rock. You can drop a rock off a cliff and it hits somebody on the bottom. You thought you were going to make a tool with the rock, but actually it slipped out of your hand and hit somebody in the eye. So there's all kinds of ways that any power that a person has can get sort of out of their control.
Yeah.
And I feel like we already for a few hundred years we have incredibly powerful tools that can go out of control. So you have a cannon, and you shoot the cannon, and you don't have control over where the cannonball lands. You have your intent, but it could miss and hit your ally instead of your enemy. And it could hit your ship instead of other countries' ship. Guns are incredibly powerful, and all kinds of people can use them in ways that they themselves don't intend. They can go off in your pocket and so on.
Sure.
And if you say, what about, we used to have missiles we still have them with atom bombs and hydrogen bombs on them, and you send them up, and then they land, and they're triggered to land someplace. But it's not all that different from, say, a drone, and you program in that it should recognize a particular person and shoot them. And it could make a mistake and shoot the wrong person, but the missile you launch could be targeted at the wrong spot and hit the wrong thing also.
Right.
So I don't, there's something scary about like a human-like thing that goes off on its own and can do the wrong thing. But I don't think it's essentially any different from any power that people have over their environment. So I don't see it as a new and different problem. If you say, well, what if all of a sudden somebody makes a walking robot that can hold a gun and can go off and do things, might it go off and do dangerous things? yes, but no more than any other tool, and you wouldn't let it do it any more than you would let any other tool do it.
Mm-hmm.
You wouldn't.
But Andy, just
yes.
let me interrupt you for a second.
Sure.
I understand what you're saying. Certainly, people who invent things, people like you, for instance, when you invent something, you have you're doing it for a very important reason. But there are a lot of people out there who want to see. They want to see war. They want to hurt people. So when you mention drones, I'm just curious, even though this may not be your area of expertise, when you mention drones, it seems like if somebody insane, somebody crazy got a hold of one, they could create an amazing amount of destruction. So if you were to think about it, what would you tell our audience? What would you say to them? Would you say that, well, there are very few people who would do that, and so it's more important to just create and invent new things? Or would you say we have to watch them, we have to regulate, we have to know a little more before we put it out there?
I have a few things to say about that. So go back to the beginning, which is that I grew up in the anti-Vietnam War era, and I'm kind of a pacifist. And in the world of robotics, I'm a near exception, and I do not accept any military money. And so all of my, most people who do robotics research have military funding, and I've never had it, and I don't ever plan to take it. On the other hand, people have said, well, you might think you're not taking military money, but if you make a good robot, the military is going to use yours just as much as anybody else's. But anyway, so yes, I don't want my research used for those purposes. But I think I go back to what I said before. It's no more true about a robot than it is about a nuclear bomb. In fact, any drone that you're thinking of is not going to be as powerful as a nuclear bomb. And everything you said about the wrong person getting their hands on it applies. Mm-hmm. So the issue is, if you make a gadget, you look at the worst thing that could happen to it. You imagine that the worst person is going to have access to this gadget, and it should be regulated in that way. Mm-hmm. If you take a car is an incredibly dangerous thing. If somebody chooses to do evil with a car, they can kill lots of people, which you've seen. If you drive into a crowd at a high speed, and you can kill 20, 30 people. Or a truck, somebody did that, right, a couple of months ago. And so you attempt to regulate them, taking into account that they can be accidentally abused or intentionally abused. And all things that are capable of being harmful have to be handled that way. Yeah.
Now, you began your research a long time ago, so I want our audience to really understand what you have discovered, and I want them to also know a little bit about your greatest accomplishments. So would you tell my audience what you've really basically discovered about robots or other things in the mechanical engineering field?
So my research started out with noticing this idea, which was noticed by someone else first, a guy named Tad McGear, and then I picked up the idea. And it's the following thing: it's that walking to some extent is automatic. And here's the idea: so if you make sticks and hinges and connect them together, so like if you think of your leg as a stick and your knee as a hinge, and your hip as a hinge, and your upper body as a stick. That's kind of a machine, and it's got muscles. But if you take that sticks and hinges like that, and you push them forward just the right way, they'll walk all by themselves. And so this first set of research I did for about 10 years was figuring out how to make walking machines that walked that didn't have any motors or any computers in them at all. And if I could just advertise my website, my last name is Ruina, R-U-I-N-A. And if you Google Ruina, or you Google Cornell walking robots or Andy walking robots, get to my webpage, and you can find videos of these robots that if you just put them on a slight downhill, they walk, and they don't have any computers, and they don't have any motors, and there's just something about the geometry of our legs makes it so we can walk automatically. So the whole first set of things we figured out is that you can do that, how energy efficient it is, what speeds you can walk, how the speed of walking depends on the step length, and so on. Then the next thing we figured out is that you can add a motor to these things and then make a very energy efficient walking robot. So our first most energy efficient walking robots are basically downhill robots with motors added to them. And we made, I think, what's still by far the most energy efficient walking robots.
Yeah.
Actually, there's a Chinese group that actually made one that's maybe about as good, like copying one of our designs.
Yeah, very interesting. Now, in the field of medicine, if somebody, we're at war in many different places, and people come home without limbs. That's unfortunate, and it's very sad. Will the robotics field or your research upon legged locomotion, would that make a difference for people who have been hurt or have lost their limbs?
I would say my hopeful answer is yes, but it's not directly what I'm working on. So the community of people I'm in works on those problems. I think they use ideas from our research, but we're not directly designing those things. So, but just to make it a sort of more direct answer, the design of prosthetic legs and the design of robotic legs is almost the same problem.
Yeah. Yeah. So how safe ought robots be prior to their introduction into the marketplace of society?
Well, I go back to my previous stand. It's like just pretend there's a new kind of car and forget whether it's robotic or not. You want things to be, one thing is you want them to be very safe if you have a well-intentioned and skilled user. And now how safe does that have to be? I think, in our society, something to be kind of acceptable has to be that it only kills, one person out of a million or something like that in a lifetime. It has to be very low chance of killing somebody in good hands. And then if it's, and then you think, what if it's in the wrong hands? Then if it's possible to cause a lot of harm, you have to, control the release of it and its ability to go out.
Yeah.
But we tolerate, our society tolerates a huge amount of stuff like that, like cars. It only takes a 1 second stray thought to kill a few people on the road by just making one swerve of the wheels.
That's correct.
And so somehow we've learned to deal with that. When you bring in a new product, it probably has to be more safe than that because you just don't know that for the most part it's going to work out. And for the most part, people don't do those crazy swerves of the steering wheels.
So, Andy, what are your biggest goals now? You've done quite a bit over the years at Cornell, and I have a suspicion you're very passionate about it because as I listen to you, I realize that you just are finding this a very exciting field. So do you have any big goals, and if so, what are they?
So a lot of people in robotics have this image of these robots walking around and serving coffee and vacuuming your house and sort of robots amongst us. And so a lot of my colleagues kind of grew up with science fiction and they kind of love robots and stuff like that. And I'm actually not one of those people. So I would like to say I love my work and I find it incredibly interesting, but I don't have this passionate goal of making robots a reality or something like that. So I have a much more humble goal, which is just to understand how robots and how people put one foot in front of the other. So, you'd say it's maybe not a very distant horizon, but it's distant enough for me. Is I would like to make a walking robot that doesn't fall down any more than a person does and doesn't use any more energy than a person does. So this would be a robot that you would, if it was in a room, you wouldn't be nervous about standing next to it because you wouldn't be afraid of it falling over any more than you're afraid of another person falling over on you. You wouldn't be afraid of it kicking you. You wouldn't be afraid for it falling down. Like when you're at a cocktail party, even with a little bit of alcohol, you're not spending all your time anxious that everybody's going to fall down. Whereas if you see almost any robot, almost any place, you're anxious about it. So I'd like to make a robot that is self-evidently, confidently, robustly walking around, and is doing that just using a little trickle of battery power, analogous to the little bit of food that we need to get around. Mm. So it's not like a way distant goal, but meaning us, this community, has been sort of working at that for, you could say 30 years, and there's no real sign that we're there, but we always think we're almost getting there.
Yeah. Every time I listen to you talk all about robots, something just kind of pops into my head. I think of Rod Serling in The Twilight Zone. It sounds a little bit like you're in the Twilight Zone because, this is a very, very interesting kind of science, and it's something that people have thought about for many, many years, but it's coming to fruition. And as it comes to fruition, I think that people like you, a professor of mechanical engineering at Cornell, will make a difference in our society. So, Andy, if people want to get in touch with you, if they want to read all about what you're doing, how do they do that?
Okay, well, we have pretty much on my website. It's not the greatest website, but if you look around, there's tons of videos. And I would say a reasonable thing to do is actually go to YouTube and look for walking robot videos. And then when you find one that's interesting to you, you click on it and find the university site where it's described. In my case, I try to write readable papers. So if you go to my website, which I said you find by Googling my last name, Ruina, or Google Andy Walking Robot or Andy Cornell Robotics. Cornell is my university. Then you'll find, you click around and you'll find papers that are, some of it will be technical jargon that a high school student might have trouble with, but some of it is not.
Good.
And now, just going back to Twilight Zone, again, it's like, I would say I'm not working on the Twilight Zone aspects of the thing. I don't know if you've seen the new TV series Black Mirror. Mm-hmm. We're not off in that direction. We're doing these things which are, it's a pun, but we're doing things which are much more pedestrian. Just to understand this basic. I guess if you think of like a car, gets around because the wheels turn, and people get around because the legs swing. We're doing the analog of just figuring out how wheels go around. We're just trying to figure out how legs swing back and forth.
Yeah.
It's not way crazy science fiction. It's very seemingly simple thing, and that's the part we're trying to figure out.
Yeah. Well, it's always great to have a guest on my show who knows so much about science, knows so much about mechanical engineering, and he's so very interesting because he's doing something that a lot of people would like to do. So today my guest was Andy Ruina, professor of mechanical engineering at Cornell University. I want to thank you, Andy Ruina, for being a guest on the Susan Brender Show. It was a pleasure to have you on.
Thanks. It's fun for me too.
Thank you for listening to the Susan Brender Show. To be a guest, email sebrender@yahoo.com.